So when we were doing products, we were multiplying into brackets. So for example, if we had 3x times 2x plus 1, right? When we want products, we multiplied or we distributed through the brackets. Okay, so words, the key words here, you would see, for example, it would say expand. Okay, that means it wants you to multiply through brackets. That's what expand means. Okay, so then here you would go 6x squared plus 3x. Okay, and then then you would say, are there any like terms to collect? You say, well, I have x's. However, don't forget, collecting like terms, everything has to match. The variable has to match and the exponents. Okay, so don't go trying to get like really compact with your answers. Okay, there comes a point where you just need to stop. So this would be an example of you have x squareds, which are not the same as x's. Okay, I know that they both have an x, but because the exponents are different, okay, this is one this is one term, this is a different term. There's no more collecting that we can do. Okay, and then we talked about how, okay, if we had, so this is a monomial times a binomial, right? One term times two terms. Okay, one term times two terms. Okay, and we just distribute through the brackets. Then we took a look at what we call binomial distribution. Okay, that's just a fancy word of looking like this. Okay, where we had two binomials and we're multiplying them. So again, remember when we have brackets like this, there's a multiplication in between them. Okay, and there was a couple things that we learned. Okay, we learned that, okay, everybody gets a turn. So we're really multiplying x by this whole bracket, and then we're multiplying 2 by the whole bracket as well. Okay, that's what's happening. But what we learned is there's a method that we use called FOIL that just sort of saves us a step in writing out our answer. Okay, so if we, like, everybody gets a turn, right? X gets multiplied by the whole bracket, then we still have to distribute. Okay, and then 2 gets multiplied through. Okay, you'll notice that when I'm multiplying a number through the bracket, my brackets drop, right? I don't need brackets anymore. Once you've done this multiplication through the brackets, you do not need brackets anymore. Okay, some people were still including brackets, which was okay sometimes, but sometimes it just kind of messed you up because suddenly you saw brackets, and instead of just collecting like terms, now you were thinking, no, I gotta multiply because I see brackets. Okay, so feel free, once you've multiplied it through the brackets, then you drop the brackets. The only time that you wouldn't drop the brackets is like in a multi-step. I'll remind you where you wouldn't drop brackets quite yet. Okay, but here you would drop the brackets, right, and collect like terms. X squared minus x minus 6. Okay, let's take this same question, x plus 2 and x minus 3, and let's do FOIL on it instead. Okay, so FOIL meant that we were doing first, outsides, insides, lasts. You'll notice that my arrows are exactly the same. I'm just bypassing this step. Because what I'm doing is I'm going to go x times x gives me x squared. X times negative 3 gives me negative 3x. 2 times x gives me 2x. And positive 2 times negative 3 gives me negative 6. Okay, now I can collect like terms. Okay, my answers are exactly the same. I just was able to condense a step by using FOIL. Okay, so just remind yourself, okay, of like kind of what it means and the different techniques that we have. Right, so we did FOIL for that. The reason I'm bringing this up, right, and kind of reminding ourselves is because, okay, these are two factors that are being multiplied together. Okay, our next step, once we did all the products, right, then we started factoring things. Okay, so we started undoing. Okay, so notice how we're now starting with, it has 3 terms. We call this a trinomial. We're starting with a trinomial, and we're trying to get back to factored form. Okay, so when we start with a trinomial, okay, and it asks you to factor it, okay, we're trying to get back to two factors being multiplied together. Okay, and so this we had a couple techniques on. Okay, our first technique, okay, don't forget we had okay, we looked at this and we said, okay, whenever we see something and we're told to factor, so here the keyword is factor. Okay, it's asking you to factor. Doesn't tell you how, it just says factor. Okay, it might tell you how, but once you get like to the end of the chapter, it'll just say factor, and you have to decide what you're going to do. So the very first thing you're doing, anybody remember the first thing that you look for when you factor? Anna, what do you look for? Yeah. Okay, the first thing you should look for is your greatest common factor, or your GCF. Okay, so we always look and we say, okay, is there anything common in both of these? Okay, and okay, so I've got a 12 and I've got an 18. What's my greatest common factor between 12 and 18? What number can those numbers be divisible by? Or what's the number that when I multiply, right, I can get to 12 and to 18? Okay, so hopefully you guys are recognizing that. Okay, 6 is your greatest common factor. A few people on the quiz did find a common factor. Okay, but they didn't find the greatest common factor. Okay, so you lost a little bit of marks because it wasn't the greatest common factor. The way that you can tell whether your factor is like the biggest one is when you factor it, okay, double check your answer that's in the brackets, your leftover factor. If there's something still common in there, okay, then you would just need to factor again. So I'll show you an example of that in a minute, okay? So here we do the numbers first, and then we do the variables. Okay, so we look and we say, oh, look, both of them have an x, so I better factor out an x, and I want to take the lowest exponent. So I can't take an x squared. I have to take just an x because the exponent is 1. And then both of these have a y, so I can grab the y as well. Okay, a lot of you were really good with this. And then I don't know if you didn't realize, but you have to take that greatest common factor and put it in front. Okay, some of you did this and then just gave me the leftover. Okay, you need to take this number and put it in front. Okay, so this is one factor. And then when we factor it out, right, we're going to have our leftover factor. So when I do this, I go 12 divided by 6. Okay, that gives me 2. I do my exponent laws, right? X to the power 2 divided by x to the power 1. We can subtract our exponents. So we're left with an x. And then the y divided by y is just 1. So it disappears, right? It cancels out. And then we go 18 divided by 6 is 3. Okay, and my x's cancel out, right? My y's cancel out, so it's just 3. Okay, so this is my leftover factor. Okay, and then this one, this is my GCF. I need to see both of them side by side. I need to see that you're multiplying them together, okay? So just double check when I hand you back your quizzes. Okay? If you see kind of like this little arrow of me writing in, kind of reminding you, don't, like you did this, okay, you found it, but don't forget you have to write it in front of your leftover factor as well, okay? So what might it look like? Let's just do this question again. Okay, what would it look like if I didn't know, or I didn't factor out 6xy? Maybe I looked at that and my brain said 3. Okay, 3 is the greatest common factor. Okay, and so maybe I did 3. And maybe I totally forgot about the x's and the y's and I just took 3 out. Okay, so if you just took 3 out, you did 12 divided by 3, which is 4. Okay, 18 divided by 3, which is 6. What I want you to take a look at when you're doing your factoring is look at your factors, right? Your leftover factors. Is there still something common here, right? they're both even. I could take out, and I could still take out a 2, right? And they both have an x. I totally forgot to take out my variable, right? And they both have a y. I could have done that too. So you have 2 options. You can either erase your work, okay, and start over again, okay, or you could pull a GCF out of this, okay? I think it's just easier at this point is just to erase it and go back up here and say, okay, my greatest common factor was not 3 because there's still things I can pull out. Okay, so let's just, okay, erase those, okay, and then pull out a higher greatest common factor, okay? So it's like you're on the right track, you understand what you're doing, you just need to make sure that you're hitting the greatest common factor, not just any factor, okay? So if you find something like 3, just double check that it can't go higher, and always double check with your, okay, whoops, with your variables, okay, so it can go a little bit higher. All right, so that was greatest common factor. That's the first one that we look at. Then the next one, okay, we talked about last week. We kind of finished up our teaching on it, but we talked about factoring by grouping, okay? What's special, like what do we have to look for in order to know that we're doing grouping? Okay, because grouping doesn't happen for like any polynomial, okay? It's like a special case. How many terms do I need in order to do grouping? Okay, yeah, 4 terms, okay? Okay, this needs 4 terms. Okay, so if you only have 2 terms, okay, you're not going to be doing grouping. If you have 3 terms, not going to be doing grouping. Okay, you need to have 4 terms to do the grouping. So in that case, let's take a look at, so turn to this. You should have all of these completed because this was homework. Okay, so if it's not done, okay, be doing it right now, right? Fill it in. I want you guys to have a complete notes package, but I also want you to have your homework done as well. I'm just going to do a little wardrobe adjustment. There we go. Okay, so let's finish these ones out. I'm only going to do a couple because we're going to move on. Yes, Sarah. Oh, yeah. 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 So it's actually easier, like when I collect homework, if it's not in your notes package, if it's on a separate sheet of paper, then you can just hand that in and I'm not having to worry about keeping hold of your notes, okay? So remember the first step that we're doing when we're doing grouping is we are, okay, just putting brackets around the first 2 terms and brackets around the last 2 terms, okay? Then we're looking for a GCF, okay? So we actually have to do it twice. So can you tell how important greatest common factors are? And that we just need lots and lots of practice because we do them like on their own, and then we also do them again when we're doing grouping. Okay, so in this case, okay, the thing that I have in common is an x that I can take out, and I'm left with the 3x, because again, x times x gives me the x squared. And then, okay, x times 1 gives me x. And here I'm going to be taking out a 2, and I'm left with an x plus 1. Okay, the nice thing with grouping is you know that you've done it right if your 2 brackets are the same. Okay, if your 2 brackets aren't the same, then like something went wrong. So say, for instance, you forgot, maybe you forgot, and you just kind of said this because, oh, x and x, and you thought, well, maybe they just kind of canceled or turned into 0 or somehow disappeared. Okay, and then when you get to here, okay, then now suddenly they don't match. And actually, they don't match anyway because I forgot the 3 in front of the x. Okay, 2 times 3 gives me 6. Sorry about that. Okay, so this is a great way to just double check. I'll clean that up a little bit for you guys. Okay, they have to match. If they don't match, you just like go back and see if you can find your error. Okay, so my error here was, okay, I forgot that x times 1 gives me x. Okay, and then from here, okay, so look at this, and I've got the brackets being the same. Let's just go back a second here to a review, okay, that we just did. Okay, notice that the first time I did distribution and I just did the x and I said x gets multiplied by this whole bracket. Guys, do you see that the brackets are exactly the same? Okay, so grouping, okay, so we can, like, the things that we're doing, this is why grouping works, right? That we went from, okay, when we expanded, we can see that our brackets are the same, and then we just distributed and collected like terms. And then that way, when we go this way for factoring, okay, we can see that when we do this grouping, that we can take the first one in the group and then multiply it by, right, that leftover factor. Okay, it goes both ways. We can put it together and then we can take it apart again. Okay, so here we're putting it together. We're going 3x plus 1 and then, okay, and then the leftover guy. Okay, let me see if there were any that I starred or thought that we needed to have a particular look at. I think these were all good. Okay, I'm going to pop down and do this bottom one here. Because again, we have this negative sign. Okay, and we just write a plus because we're not changing this into a multiplication. We're just grouping, but when we group those last two terms, we're including the negative sign. Okay, so that our brackets at the end, so that everything matches. So again, I'm taking out a greatest common factor, 2x. I'm left with 2 plus, whoops, I'm left with, oh dear, let's erase that. I'm left with x plus 2. Okay, and then here I'm taking out, remember how I said if your first term is negative, take a negative, like take a negative number with your greatest common factor. Okay, so we're taking out a negative 3, and then I'm left with 2x. Not a 3, I want a 6. Okay, minus 6, and I'm left with an x, okay, plus 2. Okay, did you see how I self-corrected there? I saw the 3 first, and then when I started taking the 3 out, I recognized that my brackets weren't going to match. So I thought, oh, wait a minute, I didn't take out a big enough greatest common factor. So it's maybe something that you can do too. Like if you started writing here like I did, okay, and say you saw the 3 first, okay, and then you got to here and recognized, wait a minute, it doesn't match. Mrs. Branch said that my brackets always have to match. Okay, so this is where you can find your own mistake. And this is how you would do it. You'd say, oh, okay, see how these are still both even? I can take another 2 out of them. So I just didn't catch my greatest common factor. Okay, so you just have to erase it. Increase your greatest common factor in order to fix your mistake. Okay, and then we have x plus 2, 2x minus 6. Okay, this one's a special circumstance because look what happened when I put the leftover factor together, 2 and a 6. Okay, I just said we didn't take out a big enough common factor. Sometimes when you combine these two terms, you create, okay, you create a situation that you just have to take out one more greatest common factor. This question actually has 3 factors. Okay, 2 in brackets, and now what's going to happen is I'm going to take out a greatest common factor for this bracket. Okay, because I could still divide both of these by 2. So that means that I can take out a 2, and I'm left with x minus 3. Okay, so I just factored this part again, and now I have an x plus 2. Okay, do you have to do that? Absolutely. Okay, every time. So just double check before you're finished with your answer. Not all of them have to be factored again, but this is a great example where when you put these two terms together, okay, it created an opportunity that you had to factor again. Okay, so now I have 3 factors, and that's okay. Okay, 2 is a factor, x minus 3 is a factor, and x plus 2 is a factor. Okay. So just to kind of be aware of it, be mindful when you're factoring to see if you've factored enough, okay, that you've done all the different factoring that you can. Okay, so I'll come around and take a look at those questions that you have, see how those went. Okay, and even the, okay, so even the solution should actually be, okay, same with this one. There. Okay, and this one. Whoops, not a 4, that should be a 2. That looks like a minus. Let me just clean it up. There. Okay. All right, so last time we introduced this idea of factoring what we call a simple trinomial. Okay, trinomial. How many terms in a trinomial? 3, absolutely. Okay, let's find out where we are in my notes. Here we go. Okay, this is what we were doing. Okay, trinomials. So I think we ended, did we finish the bottom here? Oh, we didn't quite finish yet. We'll do a couple more just to remind yourselves how to factor trinomials. It has been an awesome weekend. I hope you guys are outside enjoying things. It was great to hear about people going camping and doing some traveling, or I think there was like golfing and all sorts of things happening this weekend. Okay, so what we discovered is, okay, with a simple trinomial, simple simply means that, okay, if we look at the x squared, there's no number in front of the x squared. Okay, that's what simple means. Okay, so that's, okay, so again, note to yourself if you need to. Okay, simple, okay, trinomial, this is a quotation mark, means that, so, okay, did I say that correctly? There's no number in front of the x squared. Is there technically a number in front of the x squared? Yeah, technically there's a 1, okay, but we don't write in the 1. Okay, so simple trinomial means that there is a 1, okay, in front of the x squared, which we don't write in, so we just write it like that. Okay, so that means that we have a simple trinomial. Okay, when we have a simple trinomial, we can do the product sum, okay, method in order to figure out what our factors are. So again, we just listed, okay, we did our product. We said, what are two numbers that multiply to give me that final number? So our product is negative 40. The sum, the same two numbers, now when we add them together, they add up to give me positive 3. Okay, and so you're thinking of what are those two numbers? Okay. Can it be 1 and 40? No. Okay, they're not going to combine to make 3. Okay, and you just go through the factors. 2 and 20. No, that doesn't sound right. 4 and 10. We're getting closer, but that's still not going to work. Oh, how about 5 and 8? Okay, so 5 times 8 will give me 40. And then if we do some sort of combination between pluses and minuses, I can have an 8 and a 5, and I can make 3 for sure. So now we just have to decide which one's positive, which one's negative. Okay, when our product is negative, we know that it has to be a positive and a negative. Okay, and if our answer is positive, then the bigger number gets to be positive and the smaller number gets to be negative. Okay. And once you have these two numbers, you can go right to factored form, x plus 8, x minus 5. Okay. Okay, so let's look at G. Same thing. We're going to do our product is negative 30. Our sum is 7. So two numbers that multiply to give me negative 30, add to give me 7. Somebody tell me what they are. You think? Yeah, sure. Okay, so if I do negative 10 and positive 3, when I add them, will I get positive 7?
Oh, no.
No. So your numbers are right. All we have to do is switch the signs. Yeah. Okay. So if you ever have that where you have the numbers, because again, you need negative 30, so one has to be positive, one has to be negative. Just double check that when you add them together, that you have the right sign in the middle. Okay, that was fantastic. And then from there, now we can go 10 plus 7, x plus 10, x minus 3. There we go. My brain was saying one thing and my hand was saying something else. Okay. All right. And then, okay, after we did, so then we took a look at this and we said, oh, wait a minute. This doesn't look like a simple trinomial anymore because it's got a number other than 1 in front of that, okay, first term. Okay, so now we're starting to stack some of the factoring methods on top of each other. So the first thing, okay, when we started, okay, Anna told us the first thing we look for is the greatest common factor. We still do, okay? We still do. The second thing, we just look at the number of terms, okay, because that will help us determine if there are, okay, if there are 4 terms, okay, then we're going to do grouping. Okay, if there are 3 terms, we're going to do product sum. I'll just shorten it like that. You guys will know what I'm talking about when I do PS, product sum method. Okay. So sometimes, okay, we get to a point where it looks like maybe we're having to do something a little bit harder. Okay. Okay. But all we have to do is take a greatest common factor out first. So we could take a 4 out of all of these terms, and now this, okay, is our simple trinomial. Okay, so I've dealt with the 4. When I do my product sum, I don't include the 4 in that at all. Okay, the 4 has already been factored out. I'm just looking at my simple trinomial, okay, which is where I'm doing my product sum from. Okay, 2 numbers that add to or multiply together to give me 20, add together to give me negative 12, and we chose negative 10 and 2. Now that 4 still has to appear. The 4 is still a factor, okay, but it sits out in front of our brackets. It's not included in those 2 brackets. Okay, and so the same thing happened here. We had to take out a greatest common factor to get our simple trinomial. Once we have the simple trinomial, we can do product sum, okay, to get our 2 factors. Okay, so let's finish up with these examples. Okay, so we have an expression. This is example 2. Okay, we have an expression, x squared plus 4x minus 5. Okay, and it can be written. Okay, it just tells us that it can be written in factored form. Awesome. Okay, the value, then once it basically says, I want you to factor this, and then I want you to like line up the factors. You tell me which one's A and which one's B. I'm going to have you like divide them. Okay. So here's what we're going to do. We're going to, okay, do we need to do greatest common factor with this guy? No, because there is no greatest common factor. There's no number in front of the x squared, so we can go right to simple trinomial. Okay, we can go right to product sum. So 2 numbers that multiply to negative 45 and add to give me positive 4. Okay, think on that. Okay, let me know if you've got it. Okay, what 2 numbers multiply to give me negative 45 and add to give me positive 4? Yeah, Maria. Yeah. Okay, so tell me about 9 and 5. Are they both positive? Are they both negative? Are 1 and 1? Okay, which one? Yeah. Okay, if we do that, okay, if I go negative 9 plus 5, do I get positive 4? Okay, so simple, right? So 9 and 5 are still right. We just swap our signs. Okay. So in this case, it does matter which one is positive and which one is negative. Okay, like when we were here, when we were just looking at the negative 45, we maybe weren't sure which one was positive and negative. So clue number 2 is the sum part. Okay, and then from there, okay, we can go x plus 9 and x minus 5. Okay, and then we look up here, and they've given us a form. Okay, and the form is x minus 9, x minus a, x plus b. Okay, all I need to do is I just need to rewrite these so that the two forms match. If I just put my x minus 5 first, and then my x plus 9, now it matches my form. Which one's a and which one's b? Okay, so this is my a here. Okay, that matches up with this one. Okay, and then my b is the positive one, which matches up with that one. Okay, and so because this is the only other thing, okay, because the form already had this, I want that in a different color. Because my form, okay, had the negative, okay, the negative is already counted for. Okay, so my a here is 5 and my b here is 9. Okay, why didn't I say my a was negative 5? Because it has a negative in front of it. Why did I get to choose to drop the negative? Okay, because it already took care of the negative for me. Okay, so this is the thing, like it's a love-hate thing, okay? It's almost like a game, like you did all the work, you got the right answer, and then you just have to pay attention to the form. If the form has a negative sign in it, then you don't have to worry about the signs. They've already covered for the sign, okay? Because if I said, so here's an example, okay? If I said that my A was negative 5, okay? If I put this in here, if I substituted a is equal to negative 5 in here, okay, this would end up being, okay. Anyway, the signs just switch, okay. So when the form gives you a negative, okay, I just want you to know that they've taken care of it, okay. And the final question here is they want you to just go b, okay, divided by a. So this one you can use your calculator because they want you to round it to the nearest tenth if necessary. So you go 9 divided by 5 equals. Okay, so here's another tip. Okay, hopefully you covered this when you've been filling out numeric response. Your numeric response box will never be negative. Okay, never. There's no negative sign, okay, in our numeric response boxes. So don't do this. Don't put a negative. If you get an answer and your answer is negative, don't just put a negative out in front. Okay, it just means that somewhere along the line you made a little mistake. Okay, I'll never ask you for a negative answer in a numeric response box. Okay, so that's another reason how I know that I had to drop the negative sign, because otherwise my answer would have been negative. What'd you get when you put that into your calculator? What's 9 divided by 5? Okay, when I'm doing these, I want you guys like to be doing the math with me, not just letting me do all the math. What'd you get, Ruby? Yeah. Okay, answer is 1.8. Okay, so each just takes a space up in the numeric response. Okay, the decimal gets its own box. All right. When factored, these two trinomials have one binomial factor in common. Okay, what is it? So basically, they just want you to factor twice and then compare the factors and see which one's the same in both of these. That's it. Okay. So here, let's do the work over here. X squared minus 10x plus 21. Let's do product sum. Two numbers that multiply to give me positive 21. Okay. When I add them, give me negative 10. Okay. You figure out what are my two factors. Okay, so tell me about 7 and 3. Are they positive? Are they negative? One of each. What do we have? Both negative. Okay, and so we do a quick little check. We say when I multiply these, a negative times a negative is a positive. Check. And when I add them together, negative 7 and another negative 3 does indeed give me negative 10. Awesome job. Okay, so that's one of them. And then we're just going to do the other one, okay, because they gave us two trinomials. So we're going to product sum this one. Product is again negative 21. This time our sum is negative 4. Okay, what new combination of 4 or of 3 and 7 can we get here? Okay, so if we have negative 7, positive 3, we just do our double check. Negative 7, positive 3 does. If I multiply them, gives me negative. Okay, when I add them together, gives me a negative. Okay, so that's well done. X plus 3. And now all we have to do is it says that these two trinomials, when we factor them, have one of their factors is the same. Okay, so we're just looking for which one's the same. Well, they look like really close, but it's only, okay, x minus 7. Those ones are the same because this one here, one's plus, one's minus. So obviously those ones aren't. Okay, and then we just match it up. Oh, I'm still in highlighter mode. That was very pretty. I like that. Okay. Okay, so do you see how, like, one question, they just get you to factor two things and then see what you have in common? Okay, and they don't need you to do anything else with the other factors. They just wanted to know which ones were common. And of course, do you see, like, they have lots of distractors in there. They give you everything that you could possibly have, and even one that you didn't have, but maybe, you know, if you flipped your signs or something like that, you could possibly get. So just be aware that when there's multiple choice, okay, be confident in your answer. Okay, you can use the multiple choice maybe as some clues, but don't get too freaked out that you're like, all the numbers that I got are there. Which one do I pick, right? You answer the question and then you just find it among the distractors. Okay, so here's another example. So answer, given the following information to answer this question. And it's got like A and B. Okay, and then we'll do a little bit of work there. Okay, so we have expression A and expression B. It says factor each expression completely. Okay, let's do that first. So we've got x squared minus 4x minus 32. Okay, we look at it, right? We inspect. Can we do GCF? Nope, we don't have to do GCF. We have three terms. So we're going to be doing product sum. Okay, we're not going to be doing grouping. Okay, so you're looking at two numbers to multiply to give you negative 32, add to give you negative 4. I feel like I'm missing out. Hey, anyone want to give this one a whirl? What two numbers could I use? Yeah, Anna. 8 and 4. Okay, that sounds good. So tell me about these numbers. Positive, negative. Yeah. Okay. So she used the clues here. We know that we needed to get a negative product, so it's got to be one of each. And our answer for the sum has to be negative, so the larger number has to be negative. Okay. So we can go x minus 8, x plus 4. Okay, that was the first one. Let's do the second one. 2x squared minus 24x plus 64. Okay, so based on inspection, this one's not a simple trinomial anymore. So let's see if we can make it simple by taking out a GCF. Okay, we can take out a 2. And then what are we left with? We have an x squared minus 12x plus 8. No, plus 32. Okay, that one we can do product sum. So our product is 32. Our sum is negative 12. I'll write them down here. Okay, 32. Okay, well, we just did 32 over here, right? So use the things that you can see that are around you that you've done before, okay, to give you a starting point, because we could, right? We can use 8 and 4 again. Yeah, Sarah. Yeah. Okay. So 2 negatives multiply to give us our positive. Negative 8 minus 4 gives us negative 12. Okay, so the 2 still hangs out in front. Okay, x minus 8, x minus 4. Okay, so now we have factored each completely. Analyze and compare the expressions. Okay, so what we're trying to do is we're just trying to find some similarities and differences. Okay, so let's say, okay, so let's do our similarities. Okay, when we're looking at both of them, I would say like they're both trinomials, right? They both have 3 terms. Okay, both expressions, okay, are trinomials. Let's look at the factored terms. Oh, both of them have a x minus 8 as a factor. Okay, we're not looking for really deep and meaningful things. We're just looking for similarities and for differences. Okay, so the fact that they both have, okay, the similar factor. Okay, both expressions have x minus 8 as a factor. Factor. There we go. I'm going to move that up a little bit. Okay, let's look at differences. Okay, so whenever you see analyze, right, you guys know that that's 2 similarities, 2 differences. Okay, we're looking for 4 things with the word analyze. Okay, you could always also think of the words like compare and contrast. Compare is, you know, what's the same. Contrast is what's different. Okay, so differences. Okay, the differences are, okay, one was a simple trinomial because it had the letter or the number in front of the x squared was a 1. And then this one is what we call a complex trinomial. Okay, so one expression is simple trinomial. Okay, a is equal to 1. Anybody know where I'm getting a from? Why would I say a is equal to 1? Okay, when you see when we generalize a trinomial, okay, we use the general term. If we don't know what any of the numbers are, we use letters. This is the general term. Okay, for a trinomial. Okay, so this general term, what I'm looking at, this is the a that I'm talking about. If a is equal to 1, right, 1x squared, we usually don't write the 1. That's why it looks like this. Okay, this is the a value right here. Okay, a is equal to 1. What's a equal to here in trinomial B? Come on, guys, it's nice and obvious. Yes, 2. Okay, it's just the number that sits in front of the x squared. Okay, so in this case, a is equal to 1. That means it's a simple trinomial, and one expression is a simple trinomial. Okay, the other is what we call a complex trinomial. Okay, A isn't equal to 1. In this case, A is equal to 2. Okay, anything else that's different? How many factors did our two trinomials have at the end? Do they have the same number of factors or different number of factors? They have different number of factors. Okay, this one has 2 factors. That one has 3. Okay, we count, if we have to take out a GCF, we count that as a factor. Okay, so the final difference here is, and I think they even made here expression A and expression B. Okay, so expression A has 2 factors. Okay, and expression B has 3 factors. Okay. Now I already assigned half of the homework, so I'm not going to take a look at that now. What I am going to do is, okay, I want to introduce, okay, our final type of factoring that we're going to learn. Okay, I've sort of introduced it here, where I've told you now that we have a simple trinomial, and we also have one called a complex trinomial. Okay, so turn the page. Okay, factoring complex trinomials. So this just means that there's a number in front of the x squared. Okay, and doing, yeah. Can you wait till just after the lesson? Okay, I just don't want you to miss the kind of the explanation of it. Okay. Okay. Okay, so what's going to happen with our complex trinomial? Okay, first of all, we're going to try, if there's a number in front of the x squared, we're always going to try GCF. Okay, sometimes a GCF will work, okay, and we'll end up with a simple trinomial. Sometimes there is no GCF and there's still a number in front of the x squared. Okay, that's what we call a complex trinomial. And it just means that we're going to have to use one of the methods that we already learned. Okay, we're going to, like, remember how with the simple trinomial, sometimes we did GCF first and then product sum. Okay, in this one, okay, we are going to end up doing, okay, we're going to be including grouping into it. Okay, we've got to do a little bit of work. We're going to do product sum and then grouping. Okay, so we're not learning kind of a brand new technique. We're just combining 2 techniques that you guys already know. Okay, and we're putting them together in order to solve what we call a complex trinomial. Okay, really great. You guys will love it. Okay, so here's how it looks. So this is just a bit of a review. Okay, it says factor the following expressions. So we take a look at this, and the first thing that we're going to do is we're going to say, oh, it has 4 terms. How about we do grouping? Okay, so if it has 4 terms, okay, we're going to do grouping. So I'm just reminding us here that this is grouping. Okay, now we have to take out a GCF, right, from the first group. Okay, so we can see that we can take out a 3 and an x from each term. And then our second group, we got to take out a GCF. We're going to take out a 2. Okay, so don't forget, when I've taken them out, I still have to write them in front. So 3x, okay, and then we have 4x plus 3. And then here's our 2, right? Our 2 that we said was our greatest common factor. It pops out in front here. And we're left with a 4x plus 3. We're really wanting to make sure that our 2 sets of brackets are the same. Okay, so now we can write our in factored form. Here's our, this now becomes our greatest common factor between these terms. And here's our leftover factor, that guy right there. Okay, so that's grouping, so that's nothing new. Okay. Okay, so in this case, okay, we're just, again, we're just practicing grouping because we're going to be doing grouping in this strategy. Okay, I can take out a 4x. In this one, negative x plus 2. You guys remember what happens if there's not like really a GCF to pull out? Yeah, we can pull out. Okay, the only thing that we can pull out now, see this term is negative. So we have to pull out a negative, and there's nothing really in common. So it kind of seems a little silly to pull out a 1, okay, but that's what we have to do. Okay, and we're going to pull out a negative 1. So in this case, let me just move it up. There we go. Okay, we pulled out an x minus 2, and then we pulled out a negative 1, and then negative 1 times x gives me my negative x. Negative 1 times negative 2 gives me a positive 2. Okay. So I think, like, just remind yourself to take a look at this one, okay, when you're doing your review. So I think if you're going to make a mistake, it would be on something like this. Okay, pulling out a negative 1. All right, and then we'll just continue. Okay, so now we just regroup them. Here's our leftover factor. Okay. So here's what happens. Okay. So we've just reviewed factoring. We talked about greatest common factor. And we've talked about trinomials. So here is our trinomial right here. Here's our example. 6x squared plus 17x minus 3. So we take a look at that and we say, oh, it's not a simple trinomial. It's a complex trinomial because there's a number in front of the x squared. Can we take out a GCF? We're hoping. We're always hoping. We're always hopeful. GCF is the easiest, okay? Can we take out a GCF? Between 6, 17, and a 3. Okay, no, there's no GCF. Okay, 17 is a prime number. Like, there's really no GCF, okay? So, first of all, okay, check for a GCF. Okay, and in this case, there's no GCF. So this is what we have to do instead, okay? So what we're going to do is we're going to do our sum and product method, okay, that we did with a simple trinomial. That part hasn't changed. Okay, so what we're going to do is, now, here's the thing that is a little different. The product are the first and the last terms multiplied together. Okay, so the product here is going to be negative 18. The sum is still the middle term. Okay, so the product has changed just slightly. It's the first and the last term multiplied together. You know what? It's actually, okay, when we did product sum, I'm just going to change my page here for a sec. Okay, just look at this example that we've already done. What is the number in front of the x squared again for simple trinomial? What do you say? It was 1. What's 21 times 1? 21. Okay, so we were actually multiplying the first and the last terms together, but we didn't really talk about it that way because the first term was always 1. So we didn't even mention it. Okay, but this is actually what we've been doing this whole time, is doing the product and sum the way that we're going to do it for, okay, our decomposition. Okay, so same thing. Okay, this part hasn't changed. What are two numbers that multiply together to give me negative 18, add to give me positive 17? What have we got? Not much of a choice. Okay, how about 1 and 18? Yeah, because 3 and 6 isn't going to get us there. 2 and 9 isn't going to get us there. Okay, so we're going to have to choose 18 and 1. Okay, now the product is negative, so one of them has to be negative, one of them has to be positive. But our sum, we want to get to 17. So that means that the sum is positive, so our biggest number is positive, and our smallest number is negative. And we just double check. Negative 1 times 18, negative 18. Okay, 18 minus 1 gives us positive 17. Okay, now instead of being able to go right to factored form, this is the difference. Okay, what happens is, okay, so here, we've determined the two integers that satisfy this product sum we have. We said 17 sorry, positive 18 and negative 1. Okay, this is what we're going to do. Replace the middle term with the two integers. Okay, so what this looks like with our example is we do this, 6x squared, okay, plus 18x minus 1x minus 3. Okay, look what I just did. If we collected like terms, did I change my expression? If we collected like terms, I would end up with 17x. Okay, so what I'm doing is the word decomposition is like a fancy science word for breaking apart. Right? When you go for a walk in the woods, okay, and you step over a rotten log, it's decomposing, right? The log is like falling apart because like all the little bugs are eating it and it's getting moldy and it's like becoming part of the ground again. Okay, it's decomposing, breaking apart. So this strategy is called decomposition because we break apart the middle term. Okay, so decomposition means break apart the middle term. Okay, now look what we have. Now we have a polynomial with 4 terms. We know how to factor that. We can do grouping. Okay, now we just do grouping on it. So factor using grouping. So we're just going to group our first 2 terms, group our last 2 terms. Don't forget, just because I included that minus sign, okay, I'm still just putting them in 2 separate groups. Okay, now we're going to, how do we do grouping? We're going to take out a GCF. Okay, we're looking at 6x squared and 18x. Okay, I can take out a 6x from both of these terms. I've got a negative 1x and a negative 3. Okay, here's that example again that I told you just to make sure that you understand. Okay, it's another one of those where it doesn't have a GCF, so we'd have to take out a 1. But because this term is negative, we're going to take out that negative 1 again. Okay, so we're left with 6x, okay, x plus 3, and we're going to go minus 1, x plus 3, okay, and then x plus 3, 6x minus 1. Okay, these are all equals. Okay, and then write the answer in factored form. So we factored using grouping, and then we wrote our answer in factored form. Okay, something a little bit different, okay, but we're doing 2 techniques that you already know. We're still doing product sum, okay. The decomposition, the breaking apart of the middle term, that's new, but once we've done that, then we do grouping. Okay, so that's my introduction. That's like my long mini lesson. Okay, we'll finish up with the lesson part tomorrow. Okay, I just want to give you guys a little bit of a brain break so you can get up and move. Okay, and make sure that you don't have any homework tonight, hopefully, because let's just go back to the bottom of this page. Okay, you guys only have 3 questions to have to do here at the end of class for your homework. So if you want to get up, stretch a little bit, grab a textbook. Okay, we're going to be doing page 166, 17A, 21C and E.